Okay, for this video, we'll be going through electrical system, which is your worksheet 3. Okay, the question says that you are given 3 identical resistors. So you should be taking note of this. That means all 3 are the same and each of resistance are. I know some of you are not very comfortable with working with algebra. So maybe we can call it 1 ohm. Or if you like, 2 ohm as well. Doesn't matter, right? But at least with numbers, you are more comfortable with it. So using the space provided, draw all possible arrangement of these 3 resistors and calculate the overall resistance in terms of R. So an example of 3 resistors in series have been drawn for you. Okay? So this is the example and it happens to be the easiest. I put 3 resistors in series. And what is the overall resistance? I just add them up. But imagine just now I say you can let all of them be 1 ohm. So eventually what is the effective resistance? Will just be 3 ohm, right? Same thing. So what other arrangements are there? What have you learned? What other arrangements are there? Parallel. So can I put all 3 in parallel? Okay, and to remind you all, parallel means that there is more than 1 path. So now there are 3 resistors. I can put them in 3 paths. So what is the effective resistance? So what's the formula for parallel? 1 over REFF equals to 1 over R plus 1 over R plus 1 over R. And because all 3 have the same value, you have the same denominator. Right? This is how we do fractions over the common denominator. Then numerator, we just add them together. And I have my 1 over REFF equals to 3 over R. And this is not the end of it. Okay, so 1 over REFF equals to 3 over R. This is not the end of it. I need to do the flip. So it becomes REFF over 1 equals to R over 3. Okay? So my REFF will be equals to R over 3. Just now remember I say let R be how many ohms? 1 ohm, right? So if we substitute R as 1, it becomes REFF equals to 1 over 3 ohm. Simple. Is that all there is? Can we come up with other combinations? Yes. How? Any other combinations? So maybe I call this A. This is B. I can have C. One more. How? Is this possible? Yes. It still involves 3 resistors, right? And this is actually quite complicated. Is it? Is it complicated? Okay, this is your R. So we can see that this resistor is in series with this parallel one. So maybe we should solve this parallel first. Okay, so I do this. Now, how do we solve these 2 resistors in parallel? We use a parallel resistor formula. 1 over REFF equals to 1 over R plus 1 over R. So eventually I will get okay, so after we have resolved this part, which is the parallel part of this circuit, we can actually replace it with the effective resistance of R over 2, isn't it? Those 2 have already been combined into one single resistor of R over 2. And now you see that the circuit, after we combine them, it becomes just a series circuit, which becomes very familiar to us. So therefore, for this new circuit or equivalent circuit is just R plus R over 2. Okay, which gives us 3R over 2 ohms. Okay, now is this the last circuit, last way of combining? Can anyone think of more ways of combining? There's actually one more. There's one. Okay, so the last one is like this. Okay. So again, we involve the 3 resistors. And you see that this arrangement is different from the rest. Of course, you can put 2 on top and 1 below. Will it be the same as 1 on top and 2 below? Same one. Right on. So which one do we solve first? The top branch or the bottom branch? Or do we parallel R and R, then R and R? Which one do we solve first? We can actually combine these two first, isn't it? So that it becomes 2R. Yes? Without involving the bottom branch at all. We do the 2R, we combine them in series first. And then we have to do our parallel resistors formula. Okay, how do we solve this? Fractions, make it into common denominator. Okay? Can, right? 1 over 2R plus 1R, common denominator is actually 2R. Right? Times 2 here, multiply by 2 here, so it's 1 plus 2. So we continue writing 1 over IFF equals to 3 over 2R. But be careful, this is not the end. We still have to flip it. We still have to flip it. So anything divided by 1 is anything. So this becomes 2R over 3. And this is your answer. So there are actually 4 ways of combining them. Okay, I would say C and D are the more difficult ones.